We're back at our training domain in our car access. Hello, my name is John Cacavaro. I am the Chief Architect of Research and Development at Radius. The last talk, and I hope that you're watching these in succession, the last talk we spoke of the Get Car repository. And we said that this was a pretty clean class, small, cyclomatic complexity was small. And if you don't know what cyclomatic complexity is, you might want to look it up. It's a measurement of code readability and code simplicity. One thing we didn't do is we didn't make this green. There's still some yellow here. We always want to leave it green. So the interesting point here is that we needed to tickle and hibernate during the get by ID because the connection will be lost by the time this method returns. And to do this, we called count, but that's giving us a yellow warning. We're going to take care of this. We're going to make this whole thing cleaner. There is a method of the car DAO, of all DAOs, that will help us. That was the property, sorry. Car DAO dot load inspection list, passing it the car. And the generated car DAO will know how to tickle that property. And that makes that a lot more clean. It says load inspection list, not count. What would you be doing with count there? So it's a cleaner way to do it, and as a benefit, we make this class green. So I like this class, but there's just one issue that's bothering me. I'm doing some cobbling here. And how do I test this logic? Well, I really can't test it outside the confines of Get Car repository, which means I really might not be hitting that code and might not be able to test that and won't be able to test it like I would want it in a nice small unit test that's isolated. So we're going to take care of that. Part of our taxonomy is our processors. So let's create a new folder and call it processor. And in this processor, we already have a processor, sorry. Actually, I already created the code ahead of time, so let's look at what I did. I created an inspection cobbler request and an interface. And this inspection cobbler class just has one method, cobble. And it takes in the request and it does the logic of cobbling here. And in that way, we can test this one section, this one piece of code, this one logic, much more easily and much more isolated. It better follows the single responsibility principle. Now we just have to call it. Import public inspection cobbler, get set, and here, sorry, the wrong method. Here we can remove this, and we can call that inspection cobbler dot cobble new inspection cobbler request. Pass it our car equals response.car, and pass it our person list equals underscore person list. And in this fashion, we can call inspection cobbler much more easily in a test. Let's spend a few more seconds with the inspection cobbler. Notice how that we are using the request pattern, but there is no response. So we're not completely using the request response pattern. I don't need a response here. Let's think about why we don't need it. there's nothing really that can go wrong. I guess the request could be null, but that's not something that I'm going to check here. I mean, if anything, if I really wanted to, then I would do an assert, a debug.assert, and I would say, request can't be null. But that's more of a programmer's check than anything. If there was a rule that said that every inspection must have an inspection ID, then potentially I could send back a validation result if there wasn't one. But that's not the requirement of our pretend application, so I won't bother with that. So I don't need my response. Okay, great. Now let's go back and let's look at our car access. So we said that there's a training database and there's a training 2, and we can't draw a line between these two because they're in different databases, and that would mess up our ORM. But yet we might want to return the inspection in person back to our user, our consumer, and the data contract. And looking at the data contract, we see that it doesn't even have the inspection yet. So what I could do is I could create the inspection object, data contract class, and type in inspection, and then type in ID and give myself all the properties, and I could etc., and I would have to line up the properties. But that's a very tedious job, and Frameworks tries to relieve you of tedious jobs, especially when there's plumbing involved. If you right-click on inspection, you will see a context-sensitive menu, and one of those items are create DCs from entity. So I can create that, and that is a complete mirror image of my inspection only as a DC. Wonderful. So I could use that. Or I could click on them both and create them at the same time, because I'm also going to need person. So now I have them both, and I'll just drag those up here. Give myself some room. Maybe draw a line here. And draw another one here. And I don't mean my inspection list and my person. That looks pretty good. However, I have a mapping problem to consider. When Frameworks generates the mappers, it looks for an entity, and then it looks for a data contract of the same name. And then it will create the map, and it will try to match up property by property, and it will transfer the information. However, with respect to inspection, there's no line between inspector and person, so there's no way for the mapper to know about it. Let's take a look at that unit to prove that out. So if I go to generate it, I go to map, and I can see I have two interesting maps here, car data contract to car entity. That's the one let's start with car entity to car data contract map. So if I would to look at this, first of all, I'm getting a whole bunch of red, and we'll deal with that in a moment. That's because I started to write the code to do the mapping. I'll clean that up. Okay. So now I want to examine this a little bit, and we can see that there's a transfer method, and it's transferring the entity ID into the DC ID, name to name, etc. That's good. It also does the fuel type because there was a relationship. It also does the car type because there was a relationship. And it will even call on the inspection list to map all the inspections of that one-to-many over to the data contract. So we got up to this point, and all is well. However, As we said, there is no link in the entity, so the map would not know what the real relationship is here between inspection and person, because there's no relationship between inspection and person and the entity model. So we're going to have to do that ourselves. We're going to create a custom mapper. We want to be able to inject ourselves in this pipeline, because the consumer of this map is just going to call this map and not call some other class. We have made provisions for this. So there is a partial method. You may or may not have used partial methods in the past. You probably haven't. But a partial method is similar to a partial class. It accounts for a method that hasn't been written yet. Let's go write that map. To do that, I'm going to create a new class. Actually, I'm going to just copy this class over. That seems to be a very effective technique. And we'll just delete everything that we don't need really quickly. I don't need to call that out. And we don't need any of this. We just want to end up with our post transfer call. And we have a pre-transfer or a post-transfer. Both of them are reasonable candidates. We'll do it on the post-transfer. Okay. Let's just clean up just to make this a little bit more readable here for our purposes. So we're dealing with a data contract car and an entity car. Wonderful. So what do we want to do? Let's go back to our map and let's look at our map. And we can see that every inspection has at most one person, but we're dealing with a car. So we'll write it for each loop. For each, the collection will be the car, access, entity. How about if I just do this? I just rename this to make it a little bit more readable for us. Do some less typing. So there's a DC and a car. What didn't I like? Oh, and partial methods, they need to be named the same as the signature. So I will put that back. So we're going to do for each inspection and the entity dot inspection list, and we need to map the person. So looking at our model again, let's map the ID and the name. So first we want to create a person. New person, and let's map to the entity. So now we're looping through the entity, so we can take inspection dot person dot ID, name equals inspection dot person dot name, and we can add that to inspection dot person equals person. We can do that, and we definitely have a problem, and we're dealing with, so we can see we have a problem here. So let's go ahead and fix that problem. Let's start by defining a little bit better our variable name. So this inspection would be an entity inspection. Entity inspection. this person would be a DC person. So let's take this, let's take that, let's take that. Now we have to find our data contract inspection. So we'll say var DC inspection equals car access car dot inspection list dot single x goes to x dot ID equals entity inspection dot ID. And now we can say DC inspection dot person equals DC dot person. Oops. DC person. And let's clean up our using statements. And that's it. Now this wasn't a lot of fun to write. This is some real plumbing code. And what will happen to you, as this happened to all of us that use frameworks, every time you have to write plumbing code, you really don't like it. Fortunately, this is a very rare situation where you have to inject yourself into the mapping pipeline. It does happen on occasion. What we could have done is we could have just created our own class and we could have mapped it outside the confines of the mapper. The problem with that is when the consumer uses the map, they're not going to know. They would really have to be in tune with this whole process with the service. Let's go back and see where we use that. Where did we do that? I think at the operation. Let's view that operation. This is the get car operation. So map car. So when I go to the map the car here, if we didn't inject ourselves to the pipeline, we would have to have an additional mapping class or additional mapping code. Here, the consumer just will naturally think, let me map. And since we wrote the code to inject ourselves into that pipeline, then everything will go smoothly. Okay. I think we're in much better shape. We have seen a processor. We have seen a custom map. We have seen a custom entity. We have seen a repository. We don't have any factories yet. There really isn't a place to work in a factory necessarily. Let's just briefly discuss factories since we're here. So what's a factory? Well, to me, that's a factory. Certainly, you're instantiating an inspection cobbler request. So that's a factory. It's not a factory that we had to write ourselves, but nonetheless, it is a factory. I would write a factory anytime that I have something complex to write and to test. This is just straight properties. If I had to do any calculations, however, or aggregations or validations or any type of coding that wasn't strict assignment coding like you see here, that's when I would write a factory. Now, although this service is not very exciting, in fact, it's very, very CRUD-like, and it doesn't show off the capabilities of frameworks very well. We tried to make it a little bit more exciting by writing cobblers, processors that is, repositories, special mappings. You won't have to do that in a lot of your services. They'll be more straightforward. Engines and asynchronous processors is when you get into code that you will have to write more processors and factories and repositories and such. Okay. Thank you for listening, and we will see you next time.